In this video, we are going to solve quadratic equation problem in 2021 A-level paper. You can see the problem in the screen. They given that k is greater than 1, and we have to show that the given quadratic equation have real distinct roots. First, we are going to find that. So I write our equation. X squared minus 2 into k plus 1x plus k minus 3 squared equals 0. To find the nature of roots, we have to find the value for the discriminant. We know the discriminant is given by b squared minus 4ac in standard form. We have to substitute value in this case. So I am going to substitute. We know that b is a coefficient of x term. So I am going to substitute it here. Minus 2 into k plus 1 square minus 4. And a is the coefficient of x squared term. It is 1. And the constant is k minus 3 square. Now I am going to expand these terms. Minus 2 square is positive 4 and k plus 1 square into minus 4 k minus 3 square. I can take 4 outside, it is a common term, and I write other terms in the square bracket. K plus 1 square minus k minus 3 square. As you can see, in the bracket there is a difference of 2 squares, so I can factorize them. So I am going to factorize them like this: k plus 1 plus k minus 3 and k plus 1 minus k plus 3. Now I am going to simplify the equation. K plus k means 2k. 1 minus 3 means minus 2. Then k is cut out. K minus k. 1 plus 3 is 4. Then 4 into 4 we know 60. We can take 2 outside as a common term. Then 16 into 2 is 32. Then we get the discriminant value 32 into k minus 1. Now we have to show this value is greater than 0, because we have to show the roots of this equation is real and distinct. To be real and distinct, we know that discriminant must be a positive value. So I can easily show that, because they given that value of k is k greater than 1. So as you can see, here is a term k minus 1. So k minus 1 term is definitely positive, since k is greater than 1. So I can say delta is greater than 0 for sure. Then roots are real and distinct. Like this we solve first part of the problem. Real and distinct. Now we move to the second part. Then they are given that let alpha and beta be these roots. Write down alpha plus beta and alpha dot beta in terms of k. Okay, now we have to write the expression for the additions of root and product of roots, and then find the value of k such that both alpha and beta are positive. First I am going to find value for the alpha plus beta and alpha dot beta. I write quadratic equation here again. X squared minus 2 into k plus 1 x plus k minus 3 squared equals 0. they given that roots of this equation is alpha and beta. So I'm going to write the expression for the alpha plus beta. In term we know that it is minus b divided by a, and I substitute values minus 2k plus 1 divided by a means 1, which becomes minus into minus plus 2k plus 1. And I'm going to find product alpha dot beta. We know that it is equal to c divided by a. C value is k minus 3 squared divided by 1, which equals to k minus 3 squared. Okay, I got the expression for the additions of root and product of roots in terms of k. Now I have to find the value range for the k, which these alpha and beta are positive. We know that in theories, to find the k values, we must consider alpha plus beta greater than 0 and alpha dot beta greater than 0, because addition of roots are positive and the product of roots are positive, then we can say both roots are positive numbers. So first I am going to find k value for this inequality. So alpha plus beta, I got value 2k plus 1 greater than 0. I am divide both sides by 2, then I obtain k plus 1 greater than 0. Then I got k value ranges greater than minus 1. And considering product, I can take k minus 3 squared greater than 0. I can write k minus 3 squared as this, k minus 3 into k minus 3. So this is a multiplication of two numbers. So if one number is positive, it is the same number. So if k minus 3 is positive, then the multiplication of roots are positive. Otherwise, if the k minus 3 is negative, then the also product of these roots are positive. So we have to consider these both situations. So I first consider positive condition. So I take k minus 3 is positive, then my k value is k greater than 3. Next time consider k minus 3 is negative, then k minus 3 value is negative, then my k value range is k smaller than 0. So now we have to find real k value range for the positive roots. So first inequality we get k greater than minus 1, then k greater than 3, k, so here I did mistake, it is k smaller than 3. So actually in this two inequalities, we know that k can get any value other than positive 3. So it is no problem, we cannot take positive 3 as a k, other any real value is possible. In this equality, they said that k greater than minus 1, but there is a problem. We know that in the first part of the problem, we have find that if k is greater than 1, if k is greater than 1, then only roots are real and distinct. If k is, we know that then we get positive value range for the root as k greater than negative 1. Can we accept this value? No, we cannot accept this value, because since k greater than minus 1 and smaller than 1, we don't get real roots real numbers for the real numbers as the roots. In this range we get complex numbers, complex solutions. So we can't accept this value. And we know that from product of roots, we know that k cannot be equals 3. So our value range must be k greater than 1 and smaller than 3, or k greater than 3. These two conditions must given us the positive roots. So these are the k value range where the alpha and beta are positive values. In next part we have to find quadratic equation whose roots are 1 divided by root alpha and 1 divided by root beta. Okay. Now I am going to find some quadratic equation whose roots are 1 over root alpha and 1 over root beta. And they given that the k value range smaller than 1k. So we know that the alpha and beta are positive. It must necessary because there is a square root and alpha beta in a square root. So if it is negative, there must be a problem. So that's why they given a k value for the alpha plus beta are positive. So quadratic equation I can write as this: x squared minus additions of two roots 1 over 1 divide 1 over root alpha plus 1 over root beta into x plus 1 over root alpha into 1 over root beta equals c. Now I am going to find value for the additions of root and multiplication of root. First I am take 1 over root alpha plus 1 over root beta. I am taking common denominator as root alpha beta. So we find value for the alpha beta, then I can find value for the root alpha beta. In numerator we get root alpha plus root beta, but we don't have any value for the root alpha plus root beta. So we have to find value for the root alpha plus root beta. So I am going to square that term. Which term? I am going to square root alpha plus root beta. Then I am going to expand it. Alpha plus 2 times root alpha beta plus beta. Then I am taking square root of both sides, root alpha root beta. I am taking alpha plus beta, then 2 root alpha and square root of. So I can substitute values. We know that alpha plus beta value is 2k plus 1 plus 2, and alpha beta value is k minus 3 square root. So I can simplify this. 2k plus 2. If we take square root of square term, square is cancelled out, then I can write it as 2 into k minus 3, and I am going to multiply 2k minus 6. Sorry, miss some terms. 2 into 1 plus 2 square root. So I can take 4k minus 4 square root, and I can take 4 outside as common term, then k minus 1 square root. We know that the square root of 4 is 2, then I can write this as 2 times square root k minus 1. So I am going to substitute that value here. 2 square root k minus 1 divided by the square root k minus 3 square, which give us final answer as 2 square root k minus 1 divided by k minus 3. So I get value for the additions of root. Now next I am going to take value for the multiplication of roots. So I am taking multiplication of root as 1 over root alpha into 1 over root beta equals 1 over root alpha dot beta, which gives us 1 over root k minus 3 square. Then I get the multiplication of root as 1 over k minus 3. Now I am going to substitute these values. X part additions of root I get as 2 square root k minus 1 divided by k minus 1 divided by k minus 3 bracket x plus product of roots 1 k minus 3 equal 0. I multiply equation by k minus 3 and obtain my final solution. K minus 3 x squared minus 2 square root k minus 1 into x plus 1 equals 0. This is the quadratic equation whose roots are 1 over root alpha and 1 over root beta. So we completely solve the quadratic equation part. The confusion of this problem is that the k range for the positive roots of given quadratic equation. So we cannot accept the minus value. I explain why we cannot accept minus 1 greater than k smaller than positive 1, because we get complex solutions here. And also we can get two values for the one product as k smaller than 3 and k greater than 3. And the final part of the problem they given one range, so don't worry about that. In this range we know that roots both are positive, then there is no problem taking square root of alpha and square root of beta. In next video I am going to talk about another quadratic equation problem and how to solve it simply. See you in next video.